Today's Leetcode challenge is a famous n queens problem. So here we are given a number n as input, which represents n by n matrix, and we have to place the queen in each row in such a way that they are following the chess rules. So here the input is n is equals to 4, and output would be all the possible solutions of placing this queen on the chessboard. So on each row we have to place the queen. So on empty columns we can represent dot, and the column in which we have placed the queen we have to mark it queen, and in place of queen we are just writing q. So that's the expected output. So in the example 1, as output it should be dot q dot dot. So here in second row the queen is present at the last column, so we have to put it as dot 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 and q, similarly like this. So there are two solutions here. I'll explain how these placements of queens are being made. So in a chess, the rules for a queen are: the queen cuts all its opponents when they are placed in the same row, column, and left diagonal and right diagonal. So on the first row I could see that there is no other queen on the same row, same column, and its diagonal left and its right diagonal. Similarly for this second row queen, so I could say there is no other queen in the same row, same column, left diagonal and right diagonal. And similarly for the third row, it's the same row, same column, and in the left diagonal I couldn't see any other queen, and similarly in the right diagonal there is no other queen. So this is one of the possible solution, and this is the second possible solution for this. So let's go to the coding part. So before proceeding towards the coding part, I would like to add some points here. First is the calculations of the left diagonal and right diagonal, that each left diagonal element will have the same values as of row plus column of the queen. So here let's start with the first queen, which is placed at row 0, which is this one, and its row is 0 and column is 1. So its left diagonal will also satisfy this property. So its left diagonal element is this one, and it's at row 1 and column 0, 0. Similarly, if we have to calculate the right diagonal values, so each queen's right diagonal elements will satisfy the property of row minus column. So here again going to the first queen, which is row 0 column 1, and its value is 0 minus 1, which is minus 1. So right diagonal element would be this one, which is row 1 and column is 2, and 1 minus 2 will makes it to minus 1. So its value is same as calculated before. So this is the formula which we have to use to check the validity, or to find out that we have to place our queen in which column. So now let's quickly move to the coding part. I have already did the coding part here. I'll explain it. I have created a set here for storing the value of left diagonal, right diagonals and the column values. Similarly, for result, I have created a list of string, and then this is our n queens problem main method, which is taking n as argument. We have created a for loop here to know the correct column number where my queen should be placed in a particular row. So I'll always start with column 0. So I know that for first case my row is 0. So I'll start with column 0, and then I have created this check validity method to find out if I can place my queen in this particular column. So if I get a yes, then I can add the left diagonal, right diagonal and that column numbers in hash set. The reason I'm adding these values in left diagonal, right diagonals and columns set is when I'm iterating for the next row, I'm aware that in my previous row the queen was placed in this column, and then I'll call the solveutil method again for the second iteration, that is to find the placement of the queen in next row. That's why I did the row plus 1. We are removing elements from left diagonal, right diagonals and column set, and this is the property of the backtracking, and we are using it here to find a correct column for a particular row. So in case for a particular row we have iterated over all the columns and we are not able to find a particular solution there, we can go back to the previous row to check for a column, to check for another column there. So that's the purpose of backtracking, and we have used that property here. So using that property we can find our valid solution, and this is the check validity method which checks for left diagonal elements, right diagonals element and already used column and the solution. So yes, that's for the coding part. I have already tested this code, and it was accepted. Thanks for watching this video.